MOS logic circuits with depletion and MOS loads. 2 input NOR gate. The first circuit to be examined in this session is the 2 input NOR gate. The circuit diagram, the logic symbol and the corresponding truth table of the gate are given in figure. The Boolean OR gate OR operation is performed by the parallel connection of the 2 enhancement type NMOS driver transistors. If the input voltage VA or the input voltage VB is equal to the logic high level, the corresponding driver transistor turns on and provides a conducting path between the output node and the ground. Hence, the output voltage becomes low. In this case, the circuit operates like a depletion load. Hence, the output voltage becomes low. In this case, the circuit operates like a depletion load inverter with respect to its static behavior. A similar result is achieved when both VA and VB are high. In this case, 2 parallel conducting paths are created between the output node and the ground. If, on the other hand, both VA and VB are low, but both driver transistors remain cut off, the output node voltage is pulled to a logic high level by the depletion type NMOS load transistors. Here you can see in this figure a 2 input depletion load NOR gate, its logic symbol and the corresponding truth table. Note that the substrates of all transistors are connected to ground. The DC analysis of the circuit can be simplified significantly by considering the structural similarities between this circuit and the simple NMOS depletion load inverter. In the following, the calculation of the output low and output high voltages will be examined. Calculation of VOH. When both input voltages VA and VB are lower than the corresponding driver threshold voltage, the driver transistors are turned off and should conduct no drain current other than the sub-threshold leakage currents that will be neglected here for simplicity. Consequently, the load device which operates in the linear region should also have zero drain current. In particular, its linear region current equation becomes ID load equal to Kn load by 2 into mod VT load VOH into VDD minus VOH minus VDD minus VOH square is equal to 0. The solution of this equation gives VOH equal to VDD. Calculation of VOL. To calculate the output low voltage VOL, we must consider 3 different cases, that is 3 different input voltage combinations which produce a conducting path from the output node to the ground. The cases are VA equal to VOH, VA equal to VOL, VA equal to VOH, VB equal to VOL, VB equal to VOH, VB equal to VOH. For the first 2 cases, 1 and 2, the NOR circuit reduces to a simple NMOS depletion load inverter, assuming that the threshold voltage of the threshold voltages of the two enhancement type driver transistors are identical. VT naught A equal to VT naught B equal to VT naught. The driver to load ratio of the corresponding inverter can be found as follows. In case 1, where driver transistor A is on and the ratio is Kr equal to K driver A by K load equal to K dash N driver W by L A by K dash N load W by L load. In this case 2, where the driver transistor B is on, the ratio is Kr is equal to K driver B by K load is equal to K dash N driver W by L B by K dash N load W by L load. The output low voltage level VOL in both cases is found by using equation as follows. VOL equal to VOH minus VT naught root over VOH minus VT naught square minus K load by K driver into mod VT load VOL square. Note that if the WL ratio of both drivers are identical, that is the WLA is equal to WLB, the output low voltage VOL values calculated for case 1 and case 2 will be identical. In case 2, where both driver transistors are turned on, the saturated load current is the sum of the two mode driver currents. ID load is equal to ID driver A plus ID driver B. K load by 2 mod VT load VOL square equal to K driver A by 2 into VA minus VB VT naught into OL minus VOL square plus K driver B 2 into VB minus VT naught VOL minus VOL square. Since the gate voltages of driver transistor equal VA equal to VB equal to VOH, we can revise an equivalent driver to load ratio for the NOR structure. Kr equal to K driver A for plus K driver B plus K load equal to K dash N driver W by L A plus W by L B by Kn dash load W by L load. Thus the NOR gate with both of its inputs tied to a logic high voltage is replaced with NMOS depletion load inverter circuit with the driver to load ratio given by the output equation. The output voltage level of this case is VOL equal to VOH minus VT naught minus root over VOH minus VT naught square minus K load by K driver A plus K driver B into VT load VOL whole square. Note that the VOL given by equation is lower than the VOL values calculated for the case 1 and for case 2 when only one input is logic high. We conclude that the worst case condition from the static operation viewpoint at its highest possible VOL value is observed in case 1 or 2. His result also suggests a simple design strategy for NOR gates. Usually we have to achieve we have to achieve a certain maximum VOL for worst case, that is when only one input is high. Thus we assume that one input is high. Thus we assume that one input either VA or VB is logic high and determine driver to load ratio of the resulting inverter using equation. Then set K driver A equal to K driver B equal to KR K load. This design choice yields two identical driver transistors which guarantee the required value of VOL. In the worst case, when both inputs are logic high, the output voltage is even lower than the required maximum VOL. The output voltage is even lower than the required maximum VOL. Thus, the design constraint is satisfied. Thank you.